Hello and welcome to our How to Pass Maths series. In maths classrooms around the country, the focus on perfection often overshadows our true potential. Comparing ourselves to perfect solutions can be discouraging, leaving many students feeling down and dejected. Good or even great attempts will often be criticised for their flaws rather than being celebrated for their merits. During exam settings, this perfectionist mindset is dangerous. One mistake can feel catastrophic, triggering a downward spiral which drains your confidence and leaves you unable to perform to your full potential. But what if we could shift our perspective? We don't have to chase the elusive goal of perfection and obsess over the inevitable mistakes which drag us down. Instead, we can focus on building a solid foundation from the ground up. If we begin by targeting a 40% passing grade, we have an achievable starting point from which we can build on. So, are you ready to transform your approach to learning maths? Join me as I help you build from the base, step by confident step, towards the heights of your potential. In the 2023 Leaving Cert exams, Maths Paper 2 was split into two sections. In Section A, you had to answer 5 out of 6 questions, worth 30 marks each. In Section B, you had to answer 3 out of 4 questions, worth 50 marks each. All in all, both sections were worth 150 marks, bringing the total to 300 marks for the paper. To achieve a passing grade of 40%, you would need to score at least 120 marks. After analysing the paper, I've pinpointed the easiest and most effective way to reach this threshold. Solving the highlighted questions would secure a passing grade. In this video, I'll guide you through the step-by-step solutions for each of these questions. This will demonstrate the minimum knowledge required to pass. If you can follow along and understand my explanations, then you can step into your own exam with confidence, knowing that you have the ability to pass the paper. Any additional knowledge you have beyond what I've covered is a bonus, allowing you to achieve even higher marks and realise your full potential. In question 1a, we are given the coordinates of 2 points, A and B. In part 1, we must find the slope of the line AB. Well, page 18 of the formula book has a result which says that the slope is equal to y2 minus y1 over x2 minus x1. To use this formula, we label our first point, A, as x1, y1, and our second point, B, as x2, y2. Subbing in these values, we get 8 minus 2 over 1 minus 4. This simplifies to 6 over minus 3, which equals minus 2. In part 2, we must work out the distance of the line segment from A to B. Again, page 18 of the formula book will help. This time, we use the result that the length of a line segment is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Just like the previous part, we label the first point, A, as x1, y1, and the second point, b, as x2, y2. Subbing these values in, we get the square root of 1 minus 4 all squared plus 8 minus 2 all squared. 1 minus 4 is minus 3, and 8 minus 2 is 6. Minus 3 squared equals 9, and 6 squared equals 36. Adding these numbers together brings us to our answer of root 45. It's perfectly fine to leave your answer like this, but if you like, you can use your calculator to convert it to decimal form. In question 4a, Rowan takes a number of free throws in a basketball match. He scores 70% of his free throws on average, and each free throw attempt can be considered independent from the others. In part 1, we must find the probability he scores his first 3 free throws. To make the calculations easier, we should begin by converting the 70% to decimal form. We do this by dividing by 100 and removing the percentage sign. This gives us 0.7. Well, to score the first 3 free throws, there's 3 things that need to happen. We need to score the first, and score the second, and score the third. Each of these events individually has a 0.7 chance of occurring. When dealing with independent events, the word "and" indicates that we should multiply together our probabilities. So our answer will be 0.7 times 0.7 times 0.7. This comes out to 0.343. In part B, we have a table which shows the number of games in which Rowan scored each of a given number of points. We must find the mean number of points per game. To calculate this, there's 2 things we need to figure out: the total points scored across all the games, and the total number of games played. The mean is found by dividing these 2 figures. Let's begin by focusing on the total points scored. Rowan scored 0 points in 4 games, which gives a total of 0 times 4 equals 0 points. He scored 6 points 5 times, which is a total of 6 times 5 equals 30 points. He scored 8 points in 4 games, which gives 8 times 4 equals 32 points. He scored 10 points twice, which totals 10 times 2 equals 20 points. He scored 12 points 3 times, giving 36 points, and 16 points once, giving us 16 points. When we add all these totals together, we can see that Rowan scored 134 points across all the games. Calculating the total number of games is more straightforward. We simply add together all the figures in the number of games row. We get 4 plus 5 plus 4 plus 2 plus 3 plus 1, which comes out to 19. To get our mean, we divide the total points scored, 134, by the total games played, 19. Typing this into our calculator, and rounding to 2 decimal places, brings us to our final answer of 7.05 points. In question 5, we are given a diagram of a circle C, inside a square, which itself is inside another circle K. We're told that the side length of the square is 12 centimeters. In part A, we must find the radius of the circle C. The key insight here is that we can shift the measurement of 12 centimeters inside the circle C to observe that it has a diameter of 12 centimeters. The radius is equal to half of the diameter, so the radius is 12 divided by 2, which is 6 centimeters. In part B, we must find the area of the circle C. Page 8 of the formula book tells us that the area of a circle with radius r is equal to pi r squared. Our circle has a radius of 6, so we can sub that in for r. 6 squared is 36, so this comes out to 36 pi. We can type this into our calculator and round to 2 decimal places to get our final answer of 113.10 centimeters squared. In question 7a, we are presented with a diagram of an inclined road. The gradient of the road is defined to be the length of BC divided by the length of AC. In the first part of the question, we must find the gradient when the lengths of BC and AC are 24 and 135 respectively. This is straightforward since we are directly provided with the two components needed for the gradient definition. The gradient is equal to the length of BC, 24, divided by the length of AC, 135. We can type this fraction into our calculator to convert it to decimal form. Then, we multiply by 100 to convert to a percentage, and round to the nearest whole number. This brings us to our final answer of 18%. In part 2, we must find the length of AC when BC is 16 metres and the gradient is 12%. Our starting point here will be the definition that the gradient is equal to BC over AC. We're told that the gradient is 12% and that BC is 16. This gives us an equation which we can solve to find the value of AC. To begin, let's convert the 12% to decimal form by dividing by 100 and removing the percentage symbol. Having AC in the bottom half of a fraction is a bit awkward, so let's get it out of there. We can do this by multiplying both sides by AC. Now, to isolate the AC term, all we have to do is remove the multiplication by 0.12. We can do this by dividing both sides by 0.12. Typing the right-hand side into our calculator and rounding to the nearest whole number gives us our final answer that the length of AC equals 133 metres. In part 3, we must use Pythagoras' theorem to find an unknown side length. We are told that BC is 27 metres and that AB is 105 metres. We must find AC, which I'll label as X in our diagram. Pythagoras' theorem states that in a right angle triangle, c² equals a squared plus b squared. C refers to the hypotenuse, which is the side located across from the right angle. In our triangle, C equals 105. A and B refer to the other two side lengths. Here, I'll set A equal to x and B equal to 27. Putting these values into the statement of the theorem tells us that 105 squared equals x squared plus 27 squared. We can solve this equation to find the value of x. To begin, let's perform some calculations. 105 squared equals 11025 and 27 squared equals 729. Now, we can remove the addition of 729 from the right by subtracting this figure from both sides. On the left, 11025 minus 729 comes out as 10296. As the final step, we need to remove the squared operator from the right-hand side. We do this by square rooting both sides. Performing the calculation on the left and rounding to the nearest whole number tells us that x equals 101 meters. In question 8, we are presented with a cylindrical paddling pool that has a diameter of 2.4 meters. In part A, we are told that the pool should be filled to a maximum depth of 0.75 meters, and we are asked to determine the volume of water needed to fill it to this level. To solve this, we'll want to use the volume of a cylinder formula from page 10 of the log tables. V equals pi r squared h. To use this result, we need to find r, the radius, and h, the height. Well, we're told that the diameter equals 2.4 meters, and the radius will be half of this, 1.2 meters. The height of the cylinder corresponds to the maximum depth of the water, 0.75 meters. We sub in r equals 1.2 and h equals 0.75 into our formula, type the result into our calculator, and then round to 2 decimal places. This gives us a final answer of 3.39 meters cubed. In B part 1, we have 3 cube-shaped pool seats, each with a side length of 0.5 meters. We must show that the total volume of the 3 seats is 0.375 meters cubed. Well, the volume of a cube is equal to the side length cubed. When the side length is 0.5 meters, our volume will be 0.5 cubed, which comes out to 0.125. Since we have 3 cube-shaped pool seats, we should multiply this number by 3 to get the total volume. This brings us to 0.375 meters cubed, which is exactly the figure we wanted to obtain. In question 9b, we are told that 500 students took a statistics test. 61 students obtained a rating of excellent. In part 1, we must figure out the percentage of students who received an excellent rating. To do this, we take the number of students who obtained an excellent rating 61, and divide by the total number of students, 500. To write it as a percentage, we should multiply by 100, which gives us a final answer of 12.2%.